Welcome to springlib.
So once again, welcome to a new problem. We're still dealing with diffraction, and you can assume that we have a diffraction grating, and there's obviously going to be light going through the grating. These are different sections of the diffraction grating, and the openings, as you can see, the gap between the gratings, we're going to call it D. This gap right here, we're going to call it D. Obviously, there's light that's coming through, and then there's diffraction that takes place, bending of light coming through. The light has wavelength of lambda, and as light comes through, it has to bounce off. On the opposite side, there's a screen. We are dealing with different orders. Remember, orders, if I think about the orders, is M, and you can have maximum or minimum order. And these orders, these orders, the maxima and the minimum, some of them can be even, and the other orders can be odd if you think about all of that. So that's what we're dealing with in this particular problem. So there's certain variables that we have to introduce in this case. We know that for maximum condition, we're going to have certain requirements. So the D is the gap between the order, and each slit, each one of these slits, as you can see, has a gap of A. So that's the width. That's the width. The width of the slit is obviously A, and D is our spacing. So the different gaps or the different slits are spaced out a distance of D, and obviously the maximum condition is going to be modeled in a certain way. We're going to get back to this. D sine theta equals to m lambda. That's our standard equation that models the maxima conditions of this grating. So our goal in this particular problem is if we have a dichotomous relationship, meaning in one sense we have opaque, and then in the other sense we have transparent sections are going to eliminate. They're going to eliminate, or they're going to get rid of the even maxima orders. So that's what we want to show in this particular problem. We want to see how we're going to get rid of even maxima orders. So the relationship is D sine theta equals to m lambda, and D equals to 2a. That's the gap. This is the width of the diffraction, and this is obviously the spacing that we're dealing with. So in our case, D equals to 2a. So since D sine theta is m lambda, we can say 2a sine theta equals to m lambda, and the minima of the single slit diffraction, the minima of the single slit diffraction is going to be given by a sine theta equals to k lambda, where we have an understanding that k as an integer is not equal to 0. That's part of the understanding in the problem. So we want to see what type of relationship will make the even maxima order disappear. So we want to see what type of relationship will make even maxima order disappear. And that means we have to run a comparison between these two equations. You can call this equation 1, or rather you can call that equation 1, and you can call this second one equation 2. So these two equations are the ones we're dealing with. A comparison of the two equations, if we compare the two equations, 1 and 2, we can say, well, if we have 2a sine theta equals to m lambda, and we have a sine theta equals to k lambda, you can see that if you divide them into each other, so we have 2a sine theta over a sine theta, and then on this side we have m lambda over k lambda. The lambdas cancel out, the a sine thetas cancel out, and now we have a new relationship. We can multiply both sides by k, so m equals to 2k. That's the relationship we have. Or you could say m equals to plus minus 2, plus minus 4, plus minus 6. So all the even orders disappear. All the even orders disappear when you end up relating those two equations. You're dividing those two equations into each other. So or another way you could say it is that if both equation 1 and equation 2, if both equation 1 and equation 2 satisfies, then the order m of the maxima disappears. The order m of the maxima disappears. So once again, just going back, the goal of the problem was to check that if you have an alternate sections on the diffraction grating, or alternate strips, if you want to call them alternate strips on the diffraction grating, then we want to see if they're going to get rid of the even maxima order. So we start with the fact that d sine theta is m lambda, d is 2a, and so 2a, we do a replacement of d in the equation. 2a sine theta is m lambda, and a sine theta is k lambda. That's the minimum case. We divide them into each other and we end up with m equals to 2k, and so all the even orders disappear. So hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.